Hi guys, I've done many videos on Bitcoin, but mostly from an economic level, nothing really technical. I reached out to Kalle Rosenbaum. He's the author of Grokking Bitcoin. It's a book that has a nice deep technical look at Bitcoin. And I decided to interview him and ask him a few questions. Check it out. I think you'll find this quite interesting as a technical look at Bitcoin and the network itself. Now, tell me a bit about this block size debate that we had a few years. Why did some people want to change all of this if it's working so well?
Yeah, so that comes down to how you view Bitcoin, what you think Bitcoin is for. Some people argued back then and still argue that Bitcoin is a payments network, that it should be easy, fast and cheap to make transactions on the Bitcoin peer-to-peer network. While others think that Bitcoin is more a settlement layer, so a base layer for other layers of software that operates on top of Bitcoin. So that's two different views of Bitcoin.
Hey guys, welcome to today's video. Now, today I have a very special guest with us. I'm talking to Kalle Rosenbaum. Kalle has been involved in the Bitcoin community and he's actually an author. He's written a book, Grokking Bitcoin, which is a technical look at the Bitcoin network. So Kalle, welcome all the way from Sweden. How are you doing?
Thank you very much. Thank you very much. It's great to be here. Thanks.
Yeah. I'm assuming it's nice and warm and still summer there in Sweden?
It is. It's a beautiful summer out here. We've had a great summer so far. And the countryside in Sweden is absolutely stunning.
Excellent. I hope to visit one day. Now,
Yeah.
Kalle, before we get deep into the technicals of Bitcoin, tell us a bit about your background and also how you first got into cryptocurrency, and blockchain and Bitcoin.
Yeah, so I'm a programmer. I studied computer science and I started working with different software companies, product companies, and I did a bit of consulting as well. So I've been doing that for 20 years now. But then Bitcoin came. I discovered Bitcoin through, I think it was Twitter. A friend of mine tweeted about something Bitcoin and I just didn't react much then. This was probably 2012. But a bit later, it popped up again in my feeds. So I thought I'd had to check it out, and there it was. So that's where I got started. Firstly, it wasn't actually so much the tech. It was more like an investment. I saw it more like an investment vehicle only. Like I didn't grasp the full picture then, of course. But I gradually became more and more involved in tech and more discover the beauty of it.
Yeah, there is a little saying that goes, once you get exposed to Bitcoin, you get exposed to tech, economics, fintech, politics, even
Absolutely.
currency, all these things. It's great, isn't it?
Yes, and I was an absolute. I was very ignorant on these topics, especially economics. So I had to learn from zero.
No, that's
Basically.
great. That's great. So we'll come back into the other aspects, but let's just dive straight into the technicals for those watching the video, right? Now, this blockchain that was built specifically for Bitcoin, they needed to solve a problem. So they built something amazing. It's a hell of a design, isn't it? Tell us a bit about, now that you've gone under the hood, what's amazing about the way this entire thing has been designed?
What's amazing is that it solves a problem, or it solves a censorship problem. Bitcoin is censorship-resistant money, and that's the thing that Bitcoin solves. It removes every censor of the system. There is no censor in Bitcoin, and we didn't have that before. So that's the big thing with Bitcoin. We could create digital money before Bitcoin as well, and there were notions of blockchains before Bitcoin as well. For example, you could view Git, the software management system, the versioning system, could be regarded as a kind of blockchain where one commits to all previous commits and so on. So the notion of a blockchain was already, well, more or less known. What wasn't known was how to update the blockchain in a censorship-resistant manner, and that was, of course, the key to Bitcoin. How to update this chain of blocks with new blocks without a central authority, and that's of course solved by proof of work.
Proof of work. So that's how
Yes.
the old transaction and consensus mechanism works. That's the secret sauce that nobody had invented before, right? Tell us a bit about, on a technical level, how these transactions actually work. I think it'll be quite interesting.
Yeah. First of all, a proof of work was actually invented before Bitcoin. So Bitcoin is just a recipe built from existing ingredients, where proof of work was one. Proof of work was invented by Adam Back in 1999, I think it was. So that was just one ingredient, but the combination of these technologies was the actual secret sauce. Yeah. So yeah, how transactions work. You have this blockchain, which is a chain of blocks. Each block commits to the previous block and so on. So you can't change anything in the blockchain without actually having to update each successor block. And those blocks contain transactions. So when you update the blockchain with a new block, you create a data structure that you put transactions in it. You put transactions in your block, and then you try to solve the proof of work for that block, which requires a lot of energy. I'm not sure if I should go into that exactly how that works. Maybe we can do that later. Or
Yeah.
So you spend a lot of energy to solve that proof of work, to find a valid proof of work for that block. And once you found that proof of work for the block, you can publish it. And this everyone can then receive that block and from the peer-to-peer network and verify it and append it to their own copy of the blockchain. So everyone will keep consensus with each other. The reason for this proof of work, the reason why it's hard to find a valid proof of work is that it should take time between blocks. It shouldn't be easy to create a block because then everyone would spam the blockchain with new blocks. So it's a spam control mechanism, more or less. And that so it's so hard to create a new block that it takes the whole network about 10 minutes to find a new block.
Right.
So that's how we keep blocks separated in time. And that is very important for inflation control, because with every new block, you create a number of coins. Now it's 6.25 new coins per block. So if we would produce blocks more often than every 10 minutes, say every 1 minute, that would increase inflation by a factor of 10. So it's to keep the inflation as it was encoded from the start. To keep that inflation, you need to keep blocks on average 10 minutes apart.
Right. That's quite interesting.
Yeah.
So just to summarize for the viewer, the sequence of blocks validated, it prevents spam, it prevents double spend transactions, it has validation across this big network, so no one actor can influence it. But also, with the 10-minute block limit, we are preventing, I would say, not just inflation, but too high of an issuance of new coins. The issuance thing has been discussed, certainly with other chains. So that's very interesting. That's an elegant design for me. Now, tell me a bit about this block size debate that we had a few years. Why did some people want to change all of this if it's working so well?
Yeah, so that comes down to how you view Bitcoin, what you think Bitcoin is for. Some people argued back then and still argue that Bitcoin is a payments network, that it should be easy, fast, and cheap to make transactions on the Bitcoin peer-to-peer network. While others think that Bitcoin is more a settlement layer, so a base layer for other layers of software that operates on top of Bitcoin. So that's two different views of Bitcoin. So some view Bitcoin as the top layer, as the application layer. I mean, the layer that you and I and everybody uses all the time, while others view it as something that's used more rarely to solve disputes. And the big blockers, that camp, was the ones who thought Bitcoin should be a payments network. And they wanted to keep it that way. And Bitcoin, it started out that way for everyone. Everyone used Bitcoin as a payment network. But to accommodate the whole world's commerce on the Bitcoin blockchain is not doable. It's simply not doable. Because it would make the blocks very big. I mean, the blocks are 10 minutes apart, right? And 10 minutes worth of world economy, world transaction is just, it's going to be gigabyte blocks.
Yeah.
And to verify a gigabyte block will take a lot of time. It's not doable on a laptop. It's not doable on a high-end machine even. So you need special data centers just to verify each blocks to keep up with the blockchain. So that's not gonna work. It's not gonna scale that way. And since every block needs to be verified by every node out there, it's gonna take a huge amount of computing resources, and it's gonna be it's gonna push a lot of users out of the of Bitcoin and force them into some trust model. They need to start trusting some other to verify the coins for them. I viewed your previous episode on Austrian economics and Bitcoin. I viewed some of it, and so they mentioned the importance of everyone being able to verify the blockchain for the system to be secure. So that's an extremely important aspect of Bitcoin. Anyone should be able to verify it.
Yeah.
And if blocks turn big, if we receive gigabyte blocks, everyone would not be able to verify the blockchain.
Right.
So that will have a centralizing effect on Bitcoin,
right,
which will harm the censorship resistance property of it.
I'm going to make a statement. Tell me if you agree, right? It seems like for where Bitcoin has evolved to, potentially global reserve currency, it's not going to be used for a cup of coffee. It's going to be highly valuable proof of work plus clean energy plus the security and hash rate we have in the Bitcoin network is probably fine for what Bitcoin wants to do. If others want to build higher performance chains from a transactional perspective, that's fine. There's room for multiple chains. What's your view?
Well, there is room for multiple chains, but I think all those chains will be anchored in Bitcoin somehow, because that's the base currency everyone wants to use. So it's going to be really, really hard for someone to come up with another totally other coin to compete with Bitcoin. So every new chain out there will somehow have a connection to Bitcoin, and they might solve some specific problem, maybe transaction speed, maybe privacy or other aspects. But I think they are all going to be based on Bitcoin. So Bitcoin will be the base layer for everything.
Okay, very interesting. Now,
that's what I think. Yeah.
But I think we're starting to, like 5 years ago, we had no idea where this was going, but we're starting to see some trends and patterns now where we can predict some of these things. Let's talk, Kalle, about wallets. Now, this is an interesting topic for me because so much has happened in Bitcoin just on the development of wallets. We started with, and I'll let you explain it better than I can, we started with the pay to public key, I think it was called, the very first wallets, and we've had many iterations. Give us a quick summary of how we've evolved on wallet technology.
All right, I'll try. Yeah, as you said, we started out, the very first payments in Bitcoin were done through something called pay to public key, which was very simple. Let me start by explaining what a transaction looks like. A general transaction looks like, think of it as a data structure with a number of inputs and a number of outputs. And the inputs of a transaction are spends outputs of previous transactions. One input spends a specific output of a previous transaction.
So hang on.
So,
this is confusing.
Yeah.
If I have 2 Bitcoin in my wallet and I send 1 Bitcoin to you, Kalle.
Yes.
How does that look?
Okay. Your wallet will create a transaction, which is a little data structure. You said you had 2 Bitcoins. Maybe you had, so that transaction that you create will spend those 2 Bitcoins and send 1 Bitcoin, put 1 Bitcoin in one of the outputs of your transaction, and you will get 1 Bitcoin in change back to yourself in the other output of that transaction, right? So you have 2 outputs in your transaction. So, and then you publish that transaction to the network, and it gets confirmed in a block eventually. And then I have 1 Bitcoin in one output, and you have 1 Bitcoin in another output. So, so then you have spent all your coins, all your Bitcoins, and created 2 new coins, 1 to me and 1 to yourself. Now I can spend that coin by creating a new transaction that uses that coin, that output, as input. I create the new transaction. I want to buy pizza. So I create a transaction with 1 input that spends the output that you created for me. So inputs spend outputs. And I create a new output for the pizza for 0.01 maybe. And I create a change output for myself for the rest, 0.99. So that's the general idea of transactions. And as you can see, coins are destroyed and created. Coins are destroyed in the inputs and created in the outputs. and the sums of the inputs and the outputs must match. So if you spend 2 Bitcoins, the outputs should be about 2 Bitcoins too.
Yeah.
So you destroy some coins and you create new coins with arbitrary denominations in the outputs, but the sums must match the inputs.
Right. Now, for people who are hearing this for the first time and they find maybe this is a bit strange, the one thing we can say is that this has been a system that's proven to work flawlessly over 10 years or 11 years, right?
Yes, and you can also view it as, it's not more strange than using coins and bills when you go to the grocery store. You hand over $100 bill to the clerk, and you get they get $20 and I get $80 back. So it's basically the same system. I think that's why we call it coin in the first place, because it mimics actual cash in that way.
So let's move on to let's move on to wallets then.
So the different payment types. Okay, so in the beginning we had pay to public key, pay to PK. So the output, in the output you have an amount and an address, more or less. Let's call it an address. It's actually a small program there, but we'll skip that. It's just an address for now. And this address back in the day was just a public key. And the one with the corresponding private key could then spend that output. So to spend the output containing this public key, you need to provide the private key in the input that spends that output. So maybe I should mention it. This is a rabbit hole, I'm sorry, but maybe I should also talk a little bit about private and public keys, because that's very important in Bitcoin. So to do this, what I just told you about, public key in the output is spent by using a private key in the to create the spending input. You need a private key and a public key, and those are generated by the wallet, by the recipient. So the recipient of this coin needs to create a private key, and from that private key they generate a public key. The private key is secret, the public key is, well, public. So when you want to send coins to me, so my wallet needs to create this key pair and send the public key to you, and then you create an output with this public key. And then when I want to spend that output, I can use my private key to sign the input. I don't put my private key in the input, but I use it to sign the input with a digital signature. And only I can do that because I'm the only one who holds the private key. So that's how pay to public key works. You create a signature with the private key that spends the output.
Just a question for some people
who
are thinking this is technical. The wallet software that you use will typically do that for you, depending on the interface, I guess.
Yes, exactly. So you won't see any private keys at all. I mean, it's just you see a balance, and you can send and receive Bitcoin, but you won't have to manage public and private keys yourself. The wallet does it for you. That's right. So that's very important.
So now we've got Segwit wallets.
Yes.
What are the technical differences here?
The technical differences is it's subtle, very subtle. Instead of having the signatures as part of the transaction itself, you put the signatures in a little data structure on the side, so to speak, as an attachment to the transaction. And that's done for technical reasons, to prevent something called transaction malleability, which means that a transaction can actually change a little bit some bad actor can change a transaction deliberately by flipping a few bits in the signatures without invalidating it. But the transaction will have the exact same effect, but it will have a different ID, so to speak. But let's not go into that because, yeah, it's maybe too technical. Anyway, Segwit, segregated witness, or Segwit in short, removes the signature data out of the transaction and puts it on the side. And to make payments to a Segwit wallet, you need a Segwit address. So it's the new address format. So we skipped the legacy address format. We started with pay to public key, and then came pay to public key hash, which is you pay to a fingerprint of the public key, not the public key itself. So in the output, you have a fingerprint of the public key. So it's just a subtle difference there as well. And those addresses are the ones that you are probably used to. It starts with a 1, and then you have a sequence of, I think, 34 characters that looks random. So that's a typical Bitcoin address, legacy Bitcoin address. And then with Segwit, you have a new address format, which starts with BC1Q. That's Segwit version 0. There's not much more to say about that, actually, but in there are two different variants of this Segwit version 0, but they both start with BC1Q, and they have 2 different lengths.
Yes.
And maybe I shouldn't go into that too deeply, but so that's yeah.
But there is something important, Kalle, that I would like to raise on Segwit wallets versus especially the first P2PK wallets. Now, we hear people trying to attack Bitcoin almost every day now. And some of them talk about how quantum computing is a threat to Bitcoin. This is misunderstood in my view, because really what they're talking about is quantum computing potentially breaking the public-private key relationship of the early wallets. So my understanding is that even if we get this breakthrough in quantum computing, it is really only the older wallets that are at risk. And that's not even the blockchain itself. It's just that certain wallets could be hacked. Tell us a bit about this. I think this is quite interesting to many people.
Yeah, I don't think that's correct, actually. I think, so first of all, I'm not a quantum computing expert in any way. I just picked up pieces from here and there. And as you say, quantum computing can break the public-private key relationship. So from a public key, you could, using quantum computing, derive a private key. But modern quantum computing is very, very far from actually achieving that from a 256-bit public key. So, I don't know how far away we are from actually achieving this, but even Segwit is not immune to this. Yeah. So yes, if a quantum computer pops up, that's a big problem for Bitcoin. But then it's also a big problem for everything else on the internet. So nothing with a sufficiently good quantum computer, nothing on the internet would work anymore, at least security. So all security on the internet will be broken, which would be a major concern for every aspect of technology.
But then can I say this? Is it generally a good idea to move to Segwit wallets, just in general?
Yes, it is a good idea to move to Segwit wallets because you will get somewhat lower transaction fees because the signature data in Segwit will get some fee discount. So it will become cheaper for you to make transactions, but it won't make your transactions more safe from quantum computing.
Right.
So I think you are equally exposed if you use Segwit as if you would use legacy addresses.
Yeah. Okay. Well, I'm glad that you cleared that up. So it's just to summarize for the viewer, move to the newer wallet technology. In general, there are benefits. The older wallets are at risk of a few things, I guess. But I guess what we're saying is nothing is truly vulnerable to quantum computing when quantum computing gets to that point. It's not at that point now. So I guess some of these attacks are still a bit speculative that we're seeing from various outlets.
Yeah, absolutely. And there are ways, I mean, probably a good enough quantum computer will not just pop out of nowhere. We will see a gradual approach. We will see a gradual improvements to quantum computing. And when people think that it's a real threat or is beginning to become a real threat, there are ways to change Bitcoin to protect against, to create quantum resistant addresses, if you will.
Well, that's a good point. People forget that Bitcoin, it's not fixed. Like the code was written 10 years ago. I mean, we had an upgrade recently, I think, Taproot, which was starting
Yes,
to roll out. Yeah. Yeah.
exactly. So yeah, Bitcoin is under constant change, and it's improving at actually the mind-blowing pace. I think it's moving really fast. I know other people think it moves too slow, but I think it's as fast as it should be. I mean,
Yeah. Balancing security and everything else.
Yeah.
So talking about some of those other people, there are some chains out there doing great things. And the one thing we hear about a lot now is DeFi and smart contracts. Now, you from a software development background, by the way, I also used to be a software developer for the first 10 years of my career. Then I got more into, not writing code, but architecture and pre-sales and things like that. But it's very interesting, even to a guy like me, what exists in the Bitcoin technology for writing smart contracts, firstly? Is it even possible?
Yeah, as I said before, in the output of the transaction, in an output of a transaction, there is a small computer program. It's called script. And you can express various things with that. For example, you can write a program that verifies a signature, for example. And that's the basic legacy way to send coins. And a Bitcoin address actually encodes that specific program that verifies the signature. And it contains a few operators. And using these operators, you can form more or less advanced scripts that can verify, for example, the script can require the spender to provide signatures from multiple keys. So you can have a multi-sig scheme where you would require 2 or 3 keys to spend the coins, for example. You can view that as some kind of smart contract. And then you can have time locks and stuff on outputs. So this output may not be spent until January 1st. Or this output may not be spent until 70 blocks has passed after this output was confirmed. Stuff like that. And this is already used for smart contracts. We have, for example, the Lightning Network, which uses this script mechanism to keep track of Lightning channels, where you can send and receive coins off chain. So you and I can set up a channel between each other using this smart contract system and send tiny amounts of coins back and forth between each other 1,000,000 times without ever hitting the blockchain. We add one transaction to the Bitcoin blockchain, and using that transaction as an anchor, you and I can start talking freely, spending coins, sending coin back and forth freely as much as we want. And then when we want to settle, we can add one more transaction to the blockchain that settles the current balance between us. And then it's settled on the blockchain. So I would call that a smart contract. So smart contracts are very well used on Bitcoin.
So we'll come back.
But you can't do everything probably on Bitcoin. But
yeah,
but pretty much.
I think this is interesting. I don't think once again, I don't think a lot of people know about this, right? So we'll come back to Lightning and layer 2 scaling. But just for the programmer who might be interested, right? So Ethereum has Solidity. So you're saying we have a script language where we can do things like declare variables, write data to the chain. If someone wants to see this, what language is it? How does it look?
In Bitcoin?
Yeah.
It is called scripts, and you can look it up on the Bitcoin wiki, for example. And there are some examples in this Grokking Bitcoin book here.
Yeah.
You don't have to buy this book if you don't want it. If you want a paper copy, you can buy it. But otherwise, it's open source, freely available on the internet. So you can maybe you can add a link to it in the show notes if you want later.
I was going to give you some good news. I did some research, and the book is available in South Africa. So there's a South African retailer. That's the good news. The bad news is I'm a very bad host. I did not read the book yet. So maybe I'll order it. But what you're saying, Kalle, is that you make it available at no cost as well. Is that what you're saying?
Yes. Yeah. It is open source, so anyone can download the source code for the book, which is it's written in something called ASCII doc, which is a text markup format.
Yeah. So viewers.
And so I published that on GitHub, and I also have published a built version on my own website. So you can go to rosenbaum.se/book to browse the book online.
Yeah, well, that's fantastic. I didn't know that. So viewers around the world, I'll put the links up and you can explore. And I think if some of you want to support Kalle as well, I'll put some links to where you can order, I think, on Amazon as well for the paper copy. That's really great.
Yeah, great.
So smart contracts on Bitcoin, right? I mean, that's good, and that just proves that it really is an advanced network. It's evolving. It's not what some people say. Let's talk about nodes quickly. And I know I'm jumping around, right? If someone is a Bitcoin enthusiast, they got involved for the investment, like us, they're now amazed by technically what is possible. Such an elegant design, this network. And we still wonder who Satoshi is. Should they look at running a node? How difficult is it to run a node? What's your view?
I think it's pretty easy to run a node if you're technically oriented, at least. You can download the node software and start it on your computer and just use it. It doesn't have to be very resource intensive. I mean, to download the full blockchain and keep it on your hard drive, it takes, I don't know, 350 gigabytes or so, but you can prune that if you want to. But so that's a different mode of operation, if you will. But if you run your own full node, you actually verify every aspect of Bitcoin yourself with your program. So you don't have to trust someone else to do it for you. And I think they made it pretty easy to install your own full node. So on Windows, Mac, or Linux, you can just download the software and start it. And then you're up and running. But if you use something called lightweight wallets, I mean mobile wallets or anything, those wallets are not full nodes. Those are so-called lightweight wallets, and they need full nodes they need to connect to full nodes in order to operate. So, and if you run your own full node, you will verify every aspect. But if you use a lightweight wallet, you can't verify every aspect of the Bitcoin network or blockchain on your phone. But there is a middle ground, or you can have the best of both worlds. That is, if you run your own Bitcoin full node in your basement, you can, in one way or the other, configure your lightweight wallet to connect to your own full node. So then you only trust your own full node. You don't have to trust someone else's node. So that's a very good way to have the best of both worlds. You have the mobility of a lightweight wallet, and you have the full verification in your basement that you can connect to. So that's otherwise, if you just install lightweight wallets, it will probably connect to some server somewhere else that you don't necessarily trust, and that might be a problem for you. But for pocket money, it might be okay, but you should be aware of the risks by trusting someone else. They can lie to you, they can hide information to you. So yes, beware of trusting other people's full nodes.
So that's interesting. That's something I wasn't aware of. But I think most of us, once you go down the rabbit hole, you get to the point of where you want to run a full node, and it's getting easier by the day to actually set up.
Yes, and also just as a learning experience, download the software, start it, and see what happens. I mean, get used to the vocabulary. Just start using it. You don't have to do it right from the very beginning. Just get your hands dirty, and you will figure it out.
Yeah. So those of you watching, if you're a Bitcoin fan, you started off with the investment, but now you're a fan, run a node. It's good for hash rate also. Or, well, you're not doing a miner, but it's good for the validations, I guess, and,
yes.
All of that. So it's adding to the community. So that's great. So I think, Kalle, we have to start wrapping up, but I think it's been very interesting so far, and we didn't cover everything, but perhaps we can chat again in the future, right? Let's talk about a couple of things. So, I don't like to worry too much about price. I think once you become a Bitcoin fan like us, it has a very big use case for the future of the globe. It's going to help a lot of people around the world. Tell us a bit about, let's say, two things. What excites you about the future of Bitcoin, and where is it going?
What excites me about the future of Bitcoin? To be honest, I don't know. I worry about stuff instead. I worry about the well-being of Bitcoin users, about the well-being of Bitcoin companies when states really start to respond to Bitcoin. I think some states will respond harshly. Some states won't. For example, El Salvador probably is a great example of the opposite. So that brings hope, a bit of hope, but I'm a bit pessimistic there. Anyway, I think powerful states will do their best to make life hard for Bitcoiners. For example, the ECB, or there's a proposal on EU level to ban anonymous Bitcoin wallets, for example.
So it just yesterday. It was just yesterday, yeah.
Yeah, and that's just one step in that direction that I'm concerned about. So we will see a lot of that, I think, from especially states that have powerful currencies.
Well, you make a good point. It's no use being blindly optimistic. We need to be realistic as well. So it's good to raise these things. But then my question is, we will see states that are very smart because they are embracing Bitcoin and it will be good for them. Do you think Bitcoin fans will do something even crazy like move across the world to different states just because they want financial freedom.
Absolutely. I know several people who do that. Absolutely. It's very common among Bitcoiners to actually move to a jurisdiction there that are more favorable for them. So I know people moving to Portugal, for example, Germany, and other places. And there's a lot of talk about moving to El Salvador now. Yeah, so that will happen.
Yeah.
The states who are the most open to Bitcoiners will probably flourish.
Yeah. Well, I mean, and if it becomes the global reserve currency or a globally accepted currency of value, those states economically will do quite well. So it will be good for them.
Yes. Yes.
Kalle, thanks. I think we almost are past 45 minutes. So much more I want to ask you, but let me thank you for a couple of things. Firstly, thanks for making time for myself and the viewers. I think many people will have learned something. I even learned a few things from this talk with you. Thanks for being such a kind person to make your book available. I was gonna, promote the book, but those of you who want to support Kalle, you can buy his book, but he has made it open sourced. You can download it, and I will put those links there in the notes of the video. And Kalle, wish you all the best in Sweden, and I really hope to chat to you again in the near future.
Yeah, thank you. This was a really, I enjoyed this conversation very much. It's lightweight and nice. Yeah.
Perfect.
So thank you. Thanks a lot for having me here.
No problem. Anytime. So viewers, I hope you enjoyed that. Any questions, you can put it in the comments, and we'll try and chat to Kalle again in the near future. So until then, have a great day.
Bye.